Please. Very front page is going to have a nice little problem on it. Why are we missing so many people? Anybody know?
Hallway.
What'd you say?
Getting back from hallway. I don't know.
I don't know either. Yesterday at this time, we were hiking to the top of a mountain to watch the sunrise. Actually, we were already up there. And check out my cool socks, people. They got the quadratic formula on them. Don't want to, but they're awesome. You wish you had some, I know.
I do. They look warm.
I don't know, I just put them on. All right, here we go. How do we start? Our job basically is to sketch this, and then we got a few questions to answer. But what do we do first? We're going to factor everything. So the bottom is easy. The top, I'm going to take a 2 out. Yeah, that seems like a reasonable idea. And then I'm going to see if by chance it groups. That does not look promising, does it? That collection of numbers there in terms of grouping. You still go to school here?
Yeah.
I haven't seen you in like 3 weeks.
It's been a couple of days.
I'm glad you're here.
Thank you.
Okay, so what do? It doesn't group. So what do? PRRs, which would be factors of 6 over factors of 1. We're leaving him out now, so we're doing 6 over 1. So I don't know. Let's see. Let's find one. I don't know. 1 doesn't work. Does negative 1 work? No. No, wait a minute. Does it? Yeah, negative 1 works. So what do I do if negative 1 works? Divide it out. So I'll do that over here. There's our 0, and we're left with x squared plus x minus 6, which factors how? X plus 3, x minus 2. This is a place where a huge mistake is made. What do I not have?
The 2.
The 2, no, what do I not have? I don't have that x plus 1 in there. And somebody said you don't have the 2 either, Mrs. Ford, and you're right. This would be my factorization. Don't forget to include the number that you factored out, if you did factor something out. And don't forget to include the number that you guessed. All right, now what do you notice? We're going to have a hole. So here is the problem on which I will focus all of my energy. Right here, this is it. This is where I'm going to focus all my energy. But I know I have a hole at the point where what? X equals 2. So I'm going to have a hole where x is 2. And how do I find y? Because I'm going to plot that hole as a point on my graph. So I need a y coordinate. How do I find the y? And you plug it in here. Never back at the beginning. You plug it in here. So plugging in 2 would give me I got 15 halves, but that might be wrong. No, I think that's right. 15 halves? So here's the point 2 comma 15 halves. Now what else do I need to put in my graph? You need all the asymptotes, okay? So where are my asymptotes? Well, I have a vertical one at x equals -2. putting it on my graph and labeling it, and then if there's a blank for it, I'm filling that in too. And there is vertical asymptote. Holes, we already did that. Alright, how about a horizontal asymptote? Do I have a horizontal asymptote? Well, it's going to be slanted because the power on top is bigger than the power on the bottom. So how do I find my slant asymptote? Synthetic division. And this is the division that I do, gang, right here. This is the division that you do. So you're going to have to FOIL all that out, which would be, what, x squared plus 4x plus 3. But it's times 2, so it's 2x squared plus 8x plus 6. Everybody agree that's my numerator? And I'm dividing it by that. So my synthetic division, I'm dividing by this, and I have 286 across the top. Drop the 2 down, so I have -4. Now, I'm not going to get 0 here, and I don't care about that now, do I? I did before. I needed that 0 before. But now I don't. Now I only care about this part. And what does it say? Y equals 2x plus 4. What's that? That's a line. That's my slant asymptote. And it's a line whose intercept is 4 and has a slope of 2. Let's see, a slope of 2. So that means, okay, I got to be careful and get this in the right spot. Okay, so it's going to look like this. Alrighty. That's my end behavior asymptote. So on the line that says end behavior asymptote, you're going to write y equals 2x plus 4. Alright, what else do I need in my picture? The zeros, or the intercept. Zeros are x-intercepts. So to find the zeros, we set our box. Remember, we're focusing on the box now. We set we put y in for 0. And what are you going to get as x values when you let y be 0? What are you going to get? -3 and -1. So your intercepts are at -1 and -3. Remember, when you put a 0 here, you bring this over and it's still 0, so you're basically just solving the numerator. What about a y-intercept? We need that too, also. How do we get a y-intercept? Plug in 0, so we'd have 2 times 3 times 1 over 2. I got 3. So my y-intercept is 3. Now at this point, you're going to sketch your picture because that's all of the important stuff. Once you get all of your asymptotes, intercepts, and holes in the picture, you're ready to either plot some extra points or just connect what you've got. Do we have enough there to figure out what it looks like? I think so. It's going to approach its asymptotes. Remember, they always do. So that piece looks like that. And then over here, you have this point, so you can imagine that it looks like that. So now we're ready to answer. We answered all the questions, all except the last question. It says, what's the limit as x approaches -2 from the left? Now, at -2, we have an asymptote. When you approach an asymptote, what are you always going to do? Either go up or go down. We are told to approach from the left. That means this side. So we're coming in this side. What is happening as we approach that asymptote? So we say positive infinity. The answer to that question would be positive infinity. If we were approaching from the right, what would the answer be? Approaching the same asymptote from the other side, we would be going negative infinity. All right? Now, let's look at number 2, question number 2 there. It says fill in the following limits. Okay, so we just have a different picture. We could be answering the very same questions about this graph, but we just have a different graph now. What's the limit? I'm looking at picture 2, which is already drawn for you. What's the limit as x approaches infinity? Where is x approaching infinity? Where are my eyes looking on the picture? Up, down, left, right? No. As x approaches infinity, I am looking to the right. Right? Now, what is happening to the picture, to the y value, to the curve, as I go to the right? It's getting closer to -1. From the top or the bottom? The top. So the answer to the first one is -1 from the top. We are approaching, as we go off the page to the right, x approaches infinity, that way. Now what about the other way? What is happening as we approach from the other direction? Isn't it the same answer? It's doing exactly the same thing. It's coming in toward its asymptote from the top. All right, now, -3. I'm approaching -3. Now I have a vertical asymptote at -3, right? What do curves always do when they approach vertical asymptotes? They go up or they go down, okay? So this says, approach your asymptote at -3 from the left. What is happening as you approach the asymptote from the left? Positive infinity. So C is positive infinity. D, now you're approaching the other asymptote, the other vertical asymptote, from the right. What happens as you approach that asymptote from the right? What's it doing? It's positive infinity also. When you approach a vertical asymptote, you have no choice. You're either going to go up or go down. They're like walls. You have to either go up or go down. Now let me add one question to that that's not there. Let's find the limit as x approaches, well, it's kind of hard to tell. Let's say as x approaches 3 from the right. All right, so what's the limit as x approaches 3 from the right? Now, is there an asymptote at 3? Where x is 3, is there an asymptote?
No.
What is there?
A 0.
There's a dot, right? And it happens to be a 0, but any dot. This conversation is any dot. If you approach a vertical asymptote, if x is approaching a vertical asymptote, you're going up or down. But if you're approaching a dot, what are you doing? No matter which direction you're coming from, if you're approaching a dot, you're just approaching that y value, aren't you? So what would be the answer to this one? 0. And if I made this a minus, it would not make a single bit of difference, because when you approach a dot, it doesn't matter which direction you're coming at from, okay? All right. Now, we're going to go ahead and do 3 so that this paper will be finished. But this is what your quiz is over right here. 3 is not on it, but we're going to do 3 for review since we have the paper out. We'll just finish it up. So problem number 3 is a rational inequality. We're going to solve that. Anybody remember how you approach something like this? Subtract the 2. Very good. Remember, this is the kind, kids, we talked about that, where did that come from? Probably here. That you are tempted to multiply, but you can't. Remember that conversation we had? You cannot multiply because you don't know if it's positive or negative. You don't know if to switch the sign or not. So we're going to subtract the 2, which is 2 over 1, and then what are we going to do? Get a common denominator, which is x plus 2, and that means we have to multiply this one by x plus 2 over x plus 2. Right? So we end up with x minus 3. Okay, watch this. This is another big error place. Minus 2x minus 4. You have to distribute all the way through there. So we have negative x minus 7 over x plus 2. We okay with that? Now, we draw a number line. Remember this? Please tell me some of this sounds vaguely familiar. Now put 2 dots on the number line. Where are those dots going to be? Negative 7 and negative 2. Now, I think everybody in the room sees negative 2. If all those negatives up there bother you, then just set it equal to 0 and solve it. Don't be guessing. Just set it equal to 0 and solve it. That tells you where the dots go. Solid, open, what about the dots? Watch it.
Not the 2.
Not the 2. The negative 2 has to stay open. This would tell me the dots are colored in, right? But can our denominator equal, can we put an x equals negative 2 into our denominator? No. So even though the sign in the problem is or equal to, that will stay open. Okay. Now what do? Pick a point. And I can pick 1 if I want. I can do all 3 if I want. I'm going to pick 1. 0's over here. I like 0. When I put in 0, I get negative 7 over 2. Is that the kind of answer that I hope to get? Yes, because that means negative, and I got negative. So these are the answers to the question. So, negative infinity to negative 7, including negative 7, or negative 2 to infinity is my answer. Remember that? All right, let's go ahead and do the back side, just for a little bit more practice. All we're doing is reviewing, so we might as well review a little bit more. Let's look at the back side. No, we're not going to do the whole packet today. That would take a long time. Maybe, if you're good. Okay, here we go. We're going to sketch this one. Now, what do you notice as I'm copying it down, or as you're looking at it? What do you notice in terms of an end behavior asymptote? It's going to be 3. The powers match this time, so there is no slant. You're going to have a horizontal asymptote at y equals 3. Now, on today's quiz, that could happen. So where it says end behavior asymptote, you would just write y equals 3. It's horizontal this time because the powers match. All right, what do I need to do now? You need to factor. Kids, it's okay to put in your horizontal asymptote. It's even okay to put in your y-intercept. But everything else, you need to factor first to make sure you don't have any holes. So, does the top factor have to be 3x and x and 2 and 1? Is that the way it factors?
Yeah.
Over x plus 1, x minus 1. So, luckily or unluckily, whichever way you feel about it, we have a hole. And my equation is not going to be this now. My equation is going to be 3x minus 2 over x minus 1. Right? And I'm going to put a hole where x is -1, because that's the factor that I canceled out. And then how will I find my y coordinate? Plug in -1 right up here. Remember, we're not dealing with this anymore. We plug it in right here. So what does that give me if I put in -1?
5/5.
Is it positive 5/2?
Yeah.
So -1, positive 5/2. Everybody with us so far? All right, how about intercepts? Where did they go? Put 0 in for x, and I get 2, so there's my y-intercept, 0, 2. Let y be 0, and I get x equals 2/3. Is that what you got? Let y be 0 and solve that equation. What am I missing? Oh, my vertical asymptote. What's my vertical asymptote? X equals 1. SA stands for Slant Asymptote. We don't have one. So we filled in all the blanks, so now we just have to draw the picture. So what do you think here? I think this is pretty easy, isn't it? What about the other half of the picture? Any ideas? Over here? Up here, yeah. How do I know it can't be down here? You could have a curve that looked that way, but why do I know it's not this one? It can't, yeah, there's no other intercept. I can't cross the axis, so I must be up there in that corner. If that confuses me, or if I'm at all unsure, what can I do? Plot a couple points over here and check it out myself. All right, let's do the next one, and then we will take our quiz. We could keep doing this for hours. All right, so here we go, real quick. All right, now, look at the next page, page 2. And it says sketch this thing. We may have already done this one. But oh well, we'll do it again. Alright, what about my end behavior asymptote? Will it be horizontal this time? No, it's definitely going to be a slant. And how do I know it's going to be slant? Because the power on top is bigger. And when the power on top is bigger, we know we're going to have a slant asymptote. Okay, well, I got to figure out what it is, but I can't do that yet. So first, let's do what? Get it factors. The top does not group, so therefore I'm going to have to go through that whole guessing thing, but it looks like 1 works, the number 1. So I'm going to go ahead and divide out 1. And sure enough it does. Now when I'm factoring, I have to get 0, right? When I'm doing my asymptote division, I don't expect 0. I'll never get 0. Okay, so what's left? X squared plus 2x minus 8? How does that factor?
X minus 2x plus 4.
X minus 2x plus 4. And don't forget
X plus 1.
x
Minus 1.
minus 1. And that's all over x minus 1, x plus 1.
Oh, I see.
What?
I noticed there's gonna be a hole.
Yes, I'm glad you noticed that, Patty, because there absolutely is going to be a hole. And Patty, where is the hole going to be?
It's going to be where x is 1.
Perfect. Now,
And we're
the
gonna
new problem, the problem that we are now dealing with is x minus 2, x plus 4 over x plus 1. That's the problem we're dealing with. So if I want to know my y coordinate, I'm going to plug my 1 in right here. So that gives me negative 1 times 5 over 2. Negative 5 halves? Double check my arithmetic.
Yep.
So 1 comma negative 5 halves. There's my hole. Okay? Now, what else? This is what we're dealing with now. What else? Vertical asymptote, where? X equals negative 1. All right, what else? Y-intercept at? Plug in 0, and when you plug in 0, I think you get negative 8.
Yeah.
So there's my y-intercept. What else?
Would that be your
We haven't done the end behavior asymptote yet. We still need to do that. Let's get our zeros on there first. Our x-intercepts. What are our x-intercepts? 2 and negative 4. So we got 2 of them. One's at 2. One's at negative 4. Right now we do need our end behavior asymptote now. We need to get him in there. So how do we find our end behavior asymptote? We do the division in the box. So we've got x squared plus 2x minus 8. We're going to divide that by negative 1. And we don't care about the remainder. What is my end behavior asymptote? Y equals x plus 1, which is a line whose intercept is 1 with a slope of 1. So there it is, y equals x plus 1. That's my end behavior asymptote. And I got it from doing the division of the problem in its reduced form. After I factored and canceled, what was left is what I divide. Now, that's all the blanks. Everything is filled in. Can you sketch the picture from this point? If you can, then you do it. If you can't, then what do you have to do? You don't have a choice. You need to plot some points. But I think we have plenty here to tell us what this thing looks like. That's supposed to not be so jiggly. And then here, this is coming out here and up here. Okay? Now let's turn that over. And again, on your quiz, you are going to be working from your graph. On this quiz, I drew another graph and asked some questions. So here we go. Let's answer the questions on the back. We're going to find the limit as x approaches infinity. Where are my eyeballs looking if x is approaching infinity? All the way to the right. Now what's happening all the way to the right? Negative 1 from the bottom. So the answer to A is negative 1 from the bottom. As you head off the page to the right, you are approaching negative 1 from the bottom. All right, what about B? You're approaching 5. Okay, now wait a minute. What's happening at 5? There's an asymptote. All right, you're gonna either go up or down. We're looking on the left side. What are we doing on the left side of 5? Going up. So the answer to B is positive infinity. You are going up on the left side of your vertical asymptote at 5. All right, what's happening at 1? I have another asymptote. I'm approaching 1, that asymptote at 1, from the right side. What's happening from the right side? Positive infinity. So the answer to C is also positive infinity. D, what's the question talking about in D? Where am I looking? Off the page to the left? What's happening as I go off the page to the left? I'm approaching -1 from the bottom again. Excluded values for number 3. This isn't on your quiz, but it's a review question. What is excluded values? There's only 1, and it is 1. Why is 1 excluded in problem number 3? Because if you put it in, you get a 0 in the denominator. Okay.
So one was the only excluded value.
The quiz is only one side of the page. I do have a correction to make. So I'll make the correction. Just sit there. You're not taking the quiz. Are you taking the quiz? Okay, we're gonna give her the quiz. And you just sit right there. And we've got so much to make up, DeAndre.
I'm scared. I was literally last night stressing so hard. I was like, dude, that's like so much
solving
more
like
difficult.
I got like -8.
Oh my gosh, I have my formula socks. Why didn't you not bring them to me? Alright, if you're in the middle, you need to move. Abby, you can sit right up here. Did everybody get a quiz? Oops, not you, again.
Thank you.
Alright, I'm gonna put the corrections on the board, then that means to do with the graphs. You can go ahead and get started on the graph. And I'll turn the video off. Remember, this period does go till 40 now.